Hello, everyone, and welcome to this workshop or course on sampling techniques in healthcare with Python. My name is Valentine, and I'll be your facilitator. In this learning experience, we are going to go through this structure. We'll get started learning about the learning outcomes of today. After that, we'll talk about what those sampling techniques that we're going to be learning will entail from a theoretical perspective. Then we'll go into a practice session where we'll get to apply those concepts using Python, the Python programming language, then talk about the next steps afterwards. So let's get started. By the end of today, we expected to have achieved these learning outcomes. So we should be able to explain the importance and applications of sampling in healthcare research. We should be able to learn how to implement various sampling techniques such as random, stratified, systematic. We'll also cover from a theoretical perspective how to do other types of sampling techniques which are called non-probability sampling techniques such as convenience sampling, etc. Also, the other learning outcome is that we should be able to gain proficiency in using Python libraries such as Pandas and NumPy for data manipulation and sampling. And we should also be able to develop the ability to critically evaluate the effectiveness of different sampling methods in healthcare studies. So yeah, let's get started. So what is sampling? So sampling generally is that process that we would normally undertake in order to select a subset of individuals or a group of individuals from a larger population within a data set. So in a country, you might have a country of 50 million people, but you would want to get a representative sample, a group that is representative of the entire population, and use that group for a particular study. The objective would be to ensure that while performing sampling would be to ensure that you get conclusions that would tell you a lot more about the entire or the larger population. So generally, the main goal of sampling is just to make inferences or conclusions or generalizations about the entire population based on the analysis of that subset. So sampling generally just involves getting a representative sample, and it can be in different scientific ways or perspectives. And we're going to get to learn more about how those samples can be arrived at. Now, when it comes to importance of sampling, there are many ways that there are many reasons that we would want to perform sampling, and one of them, actually three of them, are cost efficiency, then there's timeliness and feasibility. Cost efficiency in the sense that you would end up using lesser resources if you were to work with a sample and do your research with a sample as opposed to doing research on an entire population. So assuming you had a population of 1 billion people, which a few countries do, then in terms of doing an entire research or study on the entire population, it would take a lot of resources. You need so many people to help you with the research to reach every person within that population, and in such a situation it may not make really sense. So the idea is just to be able to get a sample, a group, or a representative sample that is going to be representative of that entire population. The second reason why we would want to perform sampling, especially in healthcare, would be because we end up spending less time with regards to our study. So instead of spending maybe a whole year, you're able now to reduce the time spent on working on your project, because you now work with a lesser number of individuals or individuals from, as opposed to just working with the entire population. So generally, sampling provides a faster way to collect and analyze data, and you can use that data maybe for data collection, analysis, etc., or even just in some situations where you need to quickly understand your population, you could do some sampling techniques and get a group that helps you to arrive at conclusions that would help in the process of interventions. Maybe there are emergencies, like maybe public health emergencies, outbreaks, and you could just use that sampling in order to get that representative, that those individuals that are representative of the entire population, and be able to make conclusions about the larger population, and as a result be able now to administer whatever what comes after. It could be interventions, health interventions, or other types of interventions. Feasibility, in some situations you might want to study specific groups of people, but due to geographical constraints or logistical constraints or even ethical constraints. So assuming you have maybe you want to study maybe a remote a population that is quite remote, and accessibility of those people is hard, then in such a situation you would try as much as you can to only work with a sample, only probably the ones that you can be able to reach. That's where you might hear about convenient sampling, which is a technique that you could also perform in order to get to, again, your inferences or generalizations that you would want at the very end. So those are just a few reasons that you'd want to perform sampling. When it comes to data science, again, still in relation to also machine learning, when you're training models, you may not necessarily work with data that captures the entire population. You might end up just working with just a sample of records that you might have, maybe a sample of transactions that you train a model on to be able to make some predictions. That's just a quick example in some emerging use cases. When it comes to types of sampling methods, there are many types. There are many sampling methods, but we normally divide them into two. So there are probability sampling techniques as well as non-probability sampling techniques. In probability sampling, we normally have these types of techniques where they work by having that each member or each individual within a population normally has some sort of known or a non-zero chance of being selected. It could be equal or not equal, but generally there is a known or non-zero chance of a member or an individual within a population being selected. The probability sampling techniques that we'll cover will include simple random sampling, stratified sampling, systematic sampling, as well as cluster sampling. On the other hand, in the other bucket, we have non-probability sampling, where not all members of a population have equal chance of being selected. So this can be in some cases where you have constraints like the ones that we talked about, geographical constraints or ethical constraints. So in such situations, you might end up performing convenience sampling, judgment or purposive sampling, or even quota sampling or snowball sampling. We'll just go quickly through now each and every sampling techniques from a theoretical perspective, and then after we'll go into probability sampling, which is what you're going to be working towards when it comes to using the Python programming language. The non-probability, we won't get to learn go a bit deeper into that. Our focus will just be on the probability sampling side with Python. So in probability sampling techniques, each member of a population usually has a known or non-zero chance of being selected. And starting off, we might want to work with what is called simple random sampling. And in such a situation, every member of the population has an equal chance of being selected. So for example, you might have maybe a researcher who wants to study the effectiveness of maybe a new drug on a population of, say, 1,000 patients. So they might use a random number generator, could be provided by maybe the tools that they're using, whether it's Python, whether it's Excel, any data analysis tool. And they would use that random number generator to select 100 patients out of the 1,000 patients for the study in a random way, ensuring that now each patient that was selected of the 100 had equal chance of being chosen. So generally, in simple random sampling, every member of a population has an equal chance of being selected. Stratified sampling. So in stratified sampling, you would have the population divided. So the entire population would be divided into subgroups, or which are known as strata, based on certain characteristics, and it could be maybe age, or it could be profession, could be city where they come from, etc. And then samples are taken from each of those subgroups. So for example, say you or a researcher might want to maybe study the maybe prevalence of diabetes in a city within a diverse population. So they might divide maybe the population into strata-based age groups, so 20 to 30, 30 to 40, 40 to 50, and then randomly select a proportionate number of individuals from each strata to ensure that they have representation from all the age groups. So yeah, so that's generally stratified sampling. Systematic sampling. In systematic sampling, every nth member of a population is selected after a random starting point. So normally you would have, say for example, in a case where you have maybe a researcher who wants maybe to survey customer satisfaction among shoppers in a mall, they might maybe randomly select a starting point. Maybe they could start during the day, maybe at 11, assuming that the shop or the shoppers in the mall start coming in from 8. They might randomly start selecting shoppers for the survey, maybe 10 or 11 randomly, then they would select a starting point, and then they would choose every 10th or shopper who passes to participate in the survey. So it could be every 10th shopper after every 10th. So the 10th one, the 20th one, the 30th one, 40th, 50th, etc. All right, cluster sampling on the other hand, in this type of sampling, you'd have the population being divided into clusters. Those clusters would be randomly selected, and then a random sample of members from these clusters would be studied. So for example, you might decide to have just as a schedule, maybe a researcher might want to study the impact maybe of a new teaching method on student performance in a school, and they might want to divide, in order to apply cluster sampling, they would divide the districts, the schools, or they would divide, so I'm just trying to look at a good example. So a researcher might want to study the impact of a new teaching method on student performance in maybe schools, but schools maybe belong in many districts. So they might divide the district into clusters based on maybe schools that are in the east, west of a district, and then randomly select a few schools, and all the students within those particular schools would be included in the study. Or another example would be, so for example, you might have still the same case of schools. So you wanted to select schools that you'd want to use in a study, and you have maybe 100 schools, but you might decide to divide those schools in based on maybe whether they offer kindergarten, or they offer maybe primary, secondary, what we call high school. You could decide to randomly select, maybe you might want to have 2 clusters, but you could randomly select the clusters that you want. So it could be that you want to, you might want to get maybe ones that have kindergarten and high school, or high school and primary. So that selection process would be random. So that way you end up with 2 different categories. So it could be that you end up with high school and kindergarten, and then all the members or the students from those 2 clusters would then be considered. But the process of randomly selecting of randomization would actually come from the idea that the decision to select maybe whether it was kindergarten or high school was done in a random approach. So we'll also get to a few examples on how to apply that using the Python programming language. Non-probability sampling, on the other hand, it's a type of sampling that does not necessarily have that all the members in a population have an equal chance of being selected. So you have convenience sampling, judgmental or purposive sampling. You also have quota sampling and snowball sampling. Convenience sampling just means that samples are selected based on availability and ease of access. So for example, you could have maybe a researcher maybe standing outside a grocery store and service the first few people, maybe first 50 people who agree to participate. And for the researcher, it's convenient because it may not it's actually easier for them to just be able to just go out and get grocery store shoppers. But again, this method is convenient because again, it may not represent the entire population of grocery shoppers. There's judgmental, purposive or purposive sampling, where samples are selected based on researchers' judgment about which members will be most useful or representative. For example, a researcher again might want to study the factors that contribute maybe to academic access among maybe students, and they might purposively just select a group of high achieving students with diverse backgrounds to just gain insights into their experiences and strategies. Quota sampling, the population will be divided into groups and samples are taken from each group to meet a predetermined quota. So a researcher might aim maybe to understand the political opinions of voters, maybe in a specific region. They would set quotas to ensure that a representation from different age groups, genders, and socioeconomic backgrounds are met, and then they would select who fits these quotas until the desired sample size is reached. Lastly, some snowball sampling. It's just involves being able to use existing study subjects to recruit future subjects from among their acquaintances. So, for example, if a researcher wants to undertake a study that involves a rare disease, and finding other respondents, or finding those respondents would be challenging. So, for example, which is usually an example normally that many people usually use when it comes to even just giving an example of snowball sampling. So if they have they want to do maybe a study on a rare disease, they'll find one particular maybe potential participant, and if they agree, they would then also ask that participant to refer them to other people they know who might also be willing to take part in that study. And those other persons, of course, would also have that rare disease. So generally, that is what we call snowball sampling. So, those are the different types of sampling techniques that we'll cover, and probability sampling techniques. And there's also the probability sampling techniques. So I think at this particular point, I'm going to ask you now to go to the description of this video and click on the link, and it should take you to this page. So the resources link should take you to sampling techniques for healthcare with Python. And we are going to cover now the application of Python programming in sampling, more specifically probability sampling. So yeah, let's do that. And you can always pause the video if you think we are a bit too fast. And, so you could always do that as well. So let's go to that. Click on the sample practice resource, and you should end up to this particular page. All right, so let's get started. The first thing that you need to do Just go to File, then Save a Copy in Drive. Should have a new copy opening in a new tab, and use that one. You can close the original one. That way you have you can save your own changes and you can refer to your own copy when you want. I'll use the practice notebook, which has all the challenges, and it's also accessible to Afterwork members. So let me open mine in playground mode. You don't have to open yours in playground, so you can work with it as it is. So the other thing, once you've saved a copy in Drive, so you need to connect your notebook to Google servers by clicking on Connect on the top right. Remember, you could always pause the video if you think you're too fast, and also rewind it. All right, prerequisites. So I forgot to put an I, so it should be prerequisites. So let's start. We'll start by importing pandas and NumPy for data manipulation. So those are two Python libraries that will come in handy. Once we've imported them, the next thing that we need to do is now to go through the first probability sampling technique, which will be simple random sampling. We mentioned that simple random sampling is that sampling technique that we can use to select a random subset of data. And it just ensures that each member or each individual within a population has an equal chance of being selected. So we have this data set, and it contains the following information. It contains patients as well as their respective information. So we are going to perform simple random sampling to select just 5 respondents from 5 patients randomly from this particular data set. And so let's do that by running the next cell. By the way, in this case, we are loading our data set into the data variable. We are previewing it using the head method. Then in the next code cell, we are using the sample method or sample function to specify the number of samples, as well as we use the random state to 1 so that we have the same number of the same random sample every time. But if we don't want a random sample every time, we can just remove this part. So if I run this, every time I'll be getting just new records. So here we have patient ID 38, 43, 38, 39, 43. If I run this, I will get different. I won't get 39, 43. I have 35, 58. So here we're using just the sample function provided by the pandas library in Python to be able to select 5 random patients. All right, let's continue. I think we should be good. Once you have gotten to have gone through that, you can work on this challenge, which just allows you also to exercise what you have learned. Just almost the same. Just allows you to perform simple random sampling on this data set. Yep. All right, systematic sampling. So systematic sampling, as we had already seen, it's a sampling technique, probability sampling technique that allows us to be able to select a sample from a larger population by selecting every nth element. So I had given you an example of every 10th element, but now in our situation, we might want to select every and maybe every 5th element. And the idea is just to be able to get a sample that's evenly distributed across a population. And in many situations, this might be slightly more efficient. It might ensure that we get records that may not be necessarily selected if you were to use simple random sampling. So let's load this data set, this new data set, which we can see here contains also patients data. We can also define a sampling interval. With some systematic sampling, we usually define a sampling interval. So here we can define that we are going to select every 5th element. For our case, we are also going to start from the first record. But yes, so let's define the sampling interval. So every 5th element. You can also do every 3rd element, every 4th element, and also perform maybe and also use the iLock approach to selecting every nth item. So in our case, we have this, as you can see here, and then display the sample. So here we have the first, this is the 5th element, this is the 5th element. etc. So if you wanted maybe to get maybe every fourth element, you just change that. So this is our fourth, our sampling interval. So every after every fourth element, maybe after 3, you could also do the same thing, etc. Now, as you might have also noticed, we are going to be starting in this particular example. We're actually starting from the first element, but we had mentioned that in systematic sampling, we might want to, we would want to start from a random point. So instead of starting from the first, we can also define randomly where we would want to start. So for example, clear this, we might want to define the starting point by using a random number. So in our case here, we would generate a random starting point between 0 and the k minus 1. K would be just the sampling interval. So assuming that we want every third element, we would want to select to start either from the first element or the second element before k. So either of the two, but now to make that decision, we use the randint function provided by the random library to be able to do that particular selection, which generally would be random. So if we start maybe if we start at maybe 0 or the first one, the third the fourth element would be 4. The next element would be the fourth one. Then we go to 7th, etc. because of k, which would be the sampling interval. And we use that within our ilog function to define that we want to start from that particular point that we made to that has been selected to now the k to select now elements, nth elements after now k, which is the value that we have defined as a sampling interval. So yeah, so that's what we do. So for example, in our case here, we have decided to start with patient ID 2. This is our random starting point, and the third element, or the next one that comes after that is now 3. It's now 5. Then after that 8, etc. I think I had mentioned. Did I say something different? Yeah, I think I mentioned. No, I think it's okay. I had mentioned. I mentioned something else, but I think it's correct. So 2, that's the starting point. The next element is 5. But if we randomly, if we run this, we're actually going to randomly select another starting point. Aside from 2, we might end up starting with maybe 1. We started with 3. So we go to 6, 9, etc. So you can see that process of systematic sampling. So you do not necessarily have a starting point that is constant throughout. So this is what you might be looking towards implementing. Okay. Pause the video, work on the challenge, and then once you're done, we can continue. All right, so moving on, we are going to learn now about stratified sampling, which is a sampling technique that we can use. And in this type of sampling, we normally have a population divided into subgroups or stratas, just based on certain criteria. So maybe you might have records that we are working with, which I'm going to quickly just load. So assuming this is our data set that contains information about insurance, maybe clients or population or customers, and we might want to just get a sample from this particular population, but now we would want to perform stratified sampling. So we would ensure that this particular population is divided into maybe a subgroup. Maybe it could be gender, it could be policy type, which we are going to use, but it could also be claim status. So we could decide to create a strata based on, so those subgroups based on those groups. So in our case, we're going to create stratas based on policy type. And then once we do that, so we're going to use the group by function to provide us with now information about all the records about with regards to those subgroups. So if we select maybe policy type, we'll have 3 or 4 different groups. And then from each and every different group, we'll select now, randomly select maybe 10th of the population, 5th of the population randomly. So that allows us to be able to have, as the final sample, in the final sample, a sample that is reflective of the policy types equally. So you might have maybe 10, maybe out of the, if you wanted a sample of 30, we would have, and we have 3 policy types, just 3 policy types, we would end up having 10, 10, 10 from each policy type. Rather than if we were to apply another method like simple random sampling, we could end up having an unequal number of policy types respondents. So you might end up even having all of them if they were equally selected. So that's what we do here. We select the we have now we define the column that we're going to use to create the strata, and here we're specifying group keys to just ensure that in our final data frame we don't have that column called policy type on the left hand side. We'd always remove to have a look at what that happens. Then once we have grouped our data by the strata, we use the apply function, and we apply this lambda function, which is another function that selects that or performs simple random sampling, and it selects 20% of the records in the different strata using just simple random sampling, and we get those records and we display them. So here we have, so in our case we have these records. We have auto, these are 4, health, these are 4, home, these are 4, life records, which are 4. So that's what stratified sampling allows us to be able to do. All right, pause the video and then work on the challenge. Cluster sampling. So this is the last technique that we're going to learn in relation to just generally sampling. So cluster sampling is this type of sampling that allows us to get a sample from a population, but initially we would need to select groups. So you see here in stratified sampling, you defined policy types, but in cluster sampling, the definition of these, the decision to select these different policy types would be done randomly. So you might decide to select maybe just 2 policy types to work with, or 3 policy types to work with, but decision to select those policy types would be random. We would use random sampling. So in cluster sampling, we would select groups of data points rather than just individual data points. And the idea is that with this approach, you can be able to reduce just the complexity of sampling larger data sets while still maintaining representatives or representation of the sample, of the representation of the entire population. So let's see how we can do that. So we are going to load our data set. So this is the data set that we work with. It contains, again, patients information. And then we define that we want to just get the clusters based on, say, could be hospital name. So we have different hospitals, but we just want to select maybe just maybe three hospitals. So here we're going to work with records which belong to just 3 hospitals. But we do not know which hospitals. We're going to perform that process in a random way. So we define that we want to get all the values from hospital name, the unique ones, which we will store in clusters. And then we use the np.random.choice to select now, or the choice function to select the 3 clusters that we want to work with, the 3 values of hospital name that we want to work with. We selected all, then we define 3, which is what we do here. Size would be n clusters, the number of clusters that we want. We don't want to replace, we might end up having multiple selections of those hospitals, so we don't want to have, we just want to have the unique ones. And we run this, and we should be able to get now our records that we are going to work with will come from now these particular categories, and then we get the records from those particular hospitals, which are the ones that you see here. But we could again decide to apply simple random sampling to this particular technique, or even other types of sampling to this particular technique once we have done that. Yes, and that's it. Work on the challenge, and then once you're done, we can continue. All right, so that's it for this particular lesson. I hope you were able to have achieved the learning outcomes that we set out to achieve from the very beginning. So these are the learning outcomes. As part of the next step, what do you do after learning about sampling? After this, you would work towards applications of the concepts that you've learned. So you could think about how you might want maybe to reinforce some of the concepts that you've learned in the past, maybe data visualization, work on data visualization projects, but the data that you would use would be data that you've sampled from a larger population. Instead of using the entire data set, you could also look into maybe even machine learning, how you could train data, even explore data, perform exploratory data analysis on data sets, and then create visualizations out of them. But the data that you'd use would need to be sampled. So this is an important concept. It's one that would come in very handy, especially when you are working on projects that are quite extensive. And so that's it generally. So well, you could still do dedicated projects in sampling, but in any case, you want maybe to perform questionnaires, or you want to study a population. Again, sampling techniques come in very handy. But unless now you might want to look and draft your own problem and look at how you can apply the same techniques too. But yeah, that's it. That's it for this particular learning experience. I hope you found it worthwhile. And if you did find it worthwhile and you would want us to continue producing such content, let us know by clicking on that like button. It just tells us that we're on the right track. And if you'd want to be informed when we post such future videos, be sure to subscribe. And see you in the next video. Of course, bye-bye.